Recursion versus looping. So reasons not to use recursion. It's less efficient, entails function calling overhead that is not necessary with a loop. Usually a solution using a loop is more evident than a recursive solution. Some examples are more easily solved with recursion than with a loop. Example is Fibonacci, where the mathematical definition lets itself to recursion. So recursive functions, best way is if you can deal with it just using loop, then use a loop. Otherwise, if you don't have a choice, then you would use a recursion. So what is a recursion? A recursion is basically a function calling another function, whether it's directly or indirectly. Since the first video kind of cut off, so what we'll do is we'll use a quick example here with Graphic. Let's create a function, a subchart here, and call it maybe menu. And then in this menu, let's do some assignments. Okay. So how do we do assignments?
We assign a variable to some value.
So let's say we say arise, and then let's call it $99. And let's create another assignment, right? So these are the declarations, right? And then maybe chicken, $2.99. So here we have a subchart, right? Let's create another subchart, and then we call this order input or something like that. Okay. Now the order input we would ask questions. How many chicken do you want? And then here we can say quantity, right? Quantity of chicken. And then let's copy this and paste it. And then change this how many chicken to how many plates of rice or something like that. And then it should be quantity of rice. Let's need to save. Let's save it on the desktop. So here we have two input questions. And then here we have a menu, right? Now, when we say, if we want to show the price here, right? How do we do it? We say each at, we put a $sign there. If this was chicken, then we'll say plus what? Chicken, like that, right? We concatenate. Same thing here. We will say each at, and then put the $sign there to show how much, and then we'd say what? Price. Okay. Now, do you think this would work if I run it?
No.
Huh?
No.
No. So what do we need to do?
You have to call the function.
We need to call this function. So we call this function right here. And then what function would this be? Menu. Okay. Now, if you call menu, now it recognizes when we say chicken here or rice here. And then here, we can basically do what? Which one are we calling here? Order input. Right? So I need to call menu. So let's run it. We'll go through here, and then we'll go through this, and then it will call the other one. Now it'll come back here. I need 2 of these, and then 3 of that. It's done. Is that what we want? We need to be able to what? See it. So how do we see it? Output. So we can output here if we want, and say what? We want display chicken, right? And plus sign, the word chicken, each at, and then plus sign, no, actually this is supposed to be chicken, right? And then this is supposed to be quantity of chicken, right? Quantity of chicken. Okay, if we just leave it like that, what happens? So we go through it. So 2 of these, 3 of that. Now all we have is what? 2 chicken each at that. It's not doing that. You see that? So if we want the other one also, we have to do what? We have to do another one, place it there, and instead of chicken, this would be what? Right? And then instead of chicken here, this would be rice. And then this would be rice. So if we run it, again, we have a main, a function calling another function. So here we have it clean, so 2 each. And of course, you have to do the calculation assignment in another one so that it would display. You see that? So we had the menu, and then the menu has order input. But order input is calling another function called what? Called subchart, menu. And then after it goes through, when we go back to main, then it's doing the calculation. You can have this too, and in another subchart. That subchart calling the order input also. Does that make sense? You have one calling another one, and so on. Okay, so this is basically what recursion is. Okay, similar to the function calling another function and so forth. All right. So again, you don't have any assignment or any what do you call project doing this, because everything you need so far you have done it up to the functions. But these are concepts that's important that you need to understand. Now the other unit that we need to go over is this unit, which covers about arrays, lists, and tuples. Now arrays, lists, and tuples, it's part of what's called data structure in computer science. It's a huge field, and in here you have dictionaries, you have sets. It's basically a way to organize data. So we'll discuss about array basics, sequences, introduction to lists, list sliding, finding items and lists with the in operator, list methods, and useful built-in functions. Copying lists, processing lists, 2-dimensional lists, tuples, plotting lists. Actually, we are not doing the last one. Okay, so an array basic. So array allows you to store a group of items of the same data type together in a memory. Why? Instead of creating multiple similar variables such as employee 1, employee 2, employee 3, and so on, it's more efficient to create just one variable. Declare string employees 50. Declare real sales amount 7. So the number in the bracket is the size of the array. So the storage location in an array are elements. Each element of the array has a unique number called subscript. Okay, so the subscript always starts with a 0. So you have 0 element. The first element is 0, basically the index. Element 0, element 1, element 2, and so forth. Okay. So assigning values can be done individually using a subscript. So you can say set number 0 equals 20. Set number, and this you can do this, but it's much more efficient to just use a loop to step through the array. So here you have hours 0 would be 40. If you wanted to access that, you would use that index. Hours 1 would be 20, hours 2 would be 15, and so forth. So arrays can be initialized to 0 or specific values. So here you have declare string day 7, Sundays, Monday, Tuesday, and so forth. Now, if I need to print Saturday, how would I print that? What index would that be?
7.
If you say 7, this would be an error. Why?
0, 1, it'd be number 6, because Sunday is 0.
There you go, because remember, it starts with the 0. Remember, it starts with 0. At first element is 0. So for us to print Saturday, then it needs to be what?
6.
Day 6. So a common error is running a loop one time more than is necessary, exceeding the bound of the array. So off by one error. So partially filled array. So sometimes an array is only partially filled. To avoid processing unfilled elements, you must have an accompanying integer variable that holds the number of items stored in the array. So when the array is empty, 0 is stored in that variable, in this variable. So the variable is incremented each time an item is added to the array. So the variable's value is used as the array size when stepping through the array. So here's an example, an array that's partially filled. So some optional topic. So the for each loop is, this type of loop is used for arrays. So some languages provide for each loop, it works with an array, iterating once for each array element. During each iteration, the loop copies an element's value to a variable. Okay. So this would be a constant integer size 5, declare integer number size, and then the numbers that you initialize into, and declare integer num. Then for each num in numbers, display num. We have what's called sequences. It's an object that contains multiple items of a data. So the items are stored in a sequence, one after another. And Python provides different types of sequences, including arrays, lists, and tuples. So the difference between these is that a list is mutable and tuple is immutable. What does that mean? A list is mutable and tuple is immutable. Right. So a list is mutable, meaning what? It can be changed, and tuple is immutable. So when you see created, you cannot change it. Okay. So a sequential search algorithm is a simple technique for finding an item in a string or a numeric array. So use a loop to sequentially step through an array. Compares each element with the value being searched for, so stops when the value is found or the end of the array is hit. You can say set found equals false, set index equal to 0, and then you use the loop. Totaling the values in an array and calculating the average. So loops are used to accumulate the values, then the total is simply divided by the size. So finding the highest and the lowest values in an array. So the highest, create a variable to hold the highest value, assign the value at element 0 to the highest, use a loop to step through the rest of the elements. Each iteration comparison is made to the highest variable. If the element is greater than the highest value, that value is then assigned to the highest variable. So the lowest, same process, but checks if the element is less than the lowest value. Copying an array can be done using loops. Okay, so index 0 to size -1, set the second array, and then the index you want, and then first array index, and then end for loop. Passing an array as an argument usually must pass the array and the size, the module call. Right? Get total numbers, and then whatever the size is in the module header. Okay, function integer get total, integer array, and then integer array size. You can have parallel arrays, so by using the same subscripts, you can establish a relationship between data stored in 2 or more arrays. So you can have names, and then the indexes, and then person 1, install, and then the address 1. So these will match, right? Person 2, and then address 1, and so forth. You can have 2-dimensional arrays. It's like several identical arrays put together. So suppose a teacher has 6 students who take 5 tests. So you can use the column for the exams and then the rows for the students. So this would be nested loop. So you have 2 size variables are required when declaring. So constant integer rows, 3 constant integer column, 4, and you declare the 2 columns. So you have for row equal to 0 to rows -1, and then for column 0 to columns -1, then display enter number input values, then rows and columns. You end the loop of the innermost and then the outer. Then we have what's called lists. So list is an object that contains multiple data items. So elements and an item is in a list, so format that you create, similar to array. Can hold items of different types. The print function can be used to display an entire list. So the list function can convert certain types of objects to lists. So You have even numbers, and then you have names. Okay. Repetition operator, so makes multiple copies of a list and joins them together. So the asterisk symbol in repetition operator when applied to a sequence and an integer. So sequence is left over and number is on the right. So general format is list and then the asterisk, then end. You had this when you were doing assignments on the solo learn. So make sure you tested that with the try it option. So you can iterate over a list using a for loop. So the format is for x in list. You have indexing is a number specifying the position of element in an array, like the elements we were talking about earlier. Enables access to individual element in a list. So like in the case of the days for Saturday, we said you would use what? 6. So that would be the index. Index of first element in the list is 0, second element 1, and so forth. So negative indices identify positions relative to the end of the list. So the index minus 1 identifies the last element, minus 2 identifies the next to the last element, and so forth. The length function, it's an index error exception is raised if an invalid index is used. So the length function returns the length of a sequence such as list. So here you can have size, length, my list. So before you do anything with the list, you can use the length to give you an idea how big that length is. So it returns the number of elements in the list so that the index of the last element is length list minus 1. So you can use it to prevent an index error exception when iterating over a list with a loop. So we already said lists are mutable. So mutable sequence, the items in the sequence can be changed. So lists are mutable, so their elements can be changed. So an expression such as list1 new value can be used to assign a new value to a list element. You must use a valid index to prevent raising of an index error exception. Concatenating lists, concatenate, join two things together. So the plus sign operator can be used to concatenate two lists. This is similar to what we have just done with the Raptor. We had quantity of chicken, right? And then we said plus, and then we said the text that we wanted. So that's called concatenation. Okay. So cannot concatenate a list with another data type, such as a number. Okay. So the plus equal to augmented assignment operator can also be used to concatenate lists. List slicing is a slice a span of items that are taken from a sequence. So list slicing formats list, and then you say start, and then the end. A span is a list containing copies of elements from the start up to but not including n. If start not specified, 0 is used for the start index. If n not a specified length list is used for the index, slicing expressions can include a step value and a negative index relative to the end. You can use the in operator to determine whether an item is contained in a list. So this in operator is more of a Boolean type, just checks if it exists or not. So the general format is item in list. So it returns true or false if the item is in the list, for true, and then false if it's not in there. So similarly, you can use the not in operator to determine whether an item is not in the list. So again, this is also another Boolean type that you can use. Okay. You have the append item used to add items to a list. Item is appended to the end of the indexing list. The index item used to determine where an item is located in the list. And returns the index of the first element in the list containing the item, so it raises a value error exception if item is not in the list. Again, these are other functions that exist in this list. So you have insert, you have sort, you have remove, and then you have reverse that you can use. Again, these are concepts that we just introduced, and you don't have any assignment on it, but it's very important that you go through it so you have an understanding. You have the delete. You have the minimum and maximum functions. These are all built-in functions. Okay, copying list. To make a copy of a list, you must copy each element of the list. Two methods to do this: creating a new empty list and using a for loop to add a copy of each element from the original list to a new list. Creating a new empty list and concatenating the old list to the new list. Again, look at that pegging, the pegging game that we looked at with the recursion using one as temporary. Okay, list 1 and list 2. Reference in the center. Processing list. List elements can be used in calculation. To calculate total of numeric values in a list, use a loop with a cumulative variable. To average the numeric values in a list, calculate the total of the values, divide the total of the values by length list. List can be passed as an argument to a function. A function can return a reference to a list to save the contents of a list to a file, use the file objects write lines method. It doesn't automatically write /n at the end of each item. Use a for loop to write the element. To read data from a file, use the file objects readLine methods. Again, you don't have an assignment on this. It's just the concept that you need, but the next course that you take, you will do reading the files and arrays. Two-dimensional list, a list that contains other lists as its elements, also known as nested list. Okay, common to think of two-dimensional lists as having rows and columns, useful for working with multiple sets of data. So to process data in a two-dimensional list, you need to use two indices, typically use nested loops to process. All right, example of that. Then we have what's called tuples. So this is an immutable sequence. So very similar to a list, once it's created, it cannot be changed. All right? It supports operations as lists, subscript indexing for retrieving elements, methods such as index, built-in functions such as len, min, max, slicing expression. So it's similar to what you have seen with lists as well, and also arrays. But the only difference here is that you cannot change it once you create. But it also doesn't support the append, remove, insert, reverse, and sort. It doesn't support those built-in functions. The advantage for using tuples over lists is processing tuples is faster than processing lists. Tuples are safe. Some operations in Python require use of tuples. And then you have list and tuple. So you have list function converts tuple to a list, and tuple function converts list to a tuple. So again, these are just concepts that you need in this. I have some videos that are already in there for arrays on extra resources or student resources that you can look at. So again, these are just concepts that we needed to go over. And in the sections that we needed here. So again, these are just concepts that we went over, but you won't need it until, you don't need these for your assignments, but you do need the classes, which we will go over. So we have these two sections that we'll go over, but you should be able to do your labs based on that. Now, I just wanted to show you also here to go over we had it down. So I kind of mentioned this last class. For this project, you're creating one more subchart. Remember, these are called subcharts. You're adding one more subchart. This subchart is the one that's doing the discount, and the discount of 10%. Anything greater than orders over than 50. So you would create a subchart where you're checking if something is, and call it maybe discount. Okay. And then here you would create a decision, basically the diamond. And here you will say if that, it could be a subtotal, whatever variable you use, greater than 50. I'm just throwing that variable in there. If subtotal is greater than 50, if it's no, you just exit and print the receipt. Okay, you can do the function call here. Okay, if it's yes, then you would do what? Discount. Right? So you would do an assignment here, and then that would be discounted discounted amount or something, right? And then here you would say discount times, because it's 10%, you can say what? 0.1. Here, then you can say discount amount. There is nothing here. Technically, actually, you can actually take out and do a function call here and then take them out, because you're not giving them any discount here. You don't need to display it. And then after you do the calculation here, you will also need what? The output, right? The output to say something like amount after discount or something like that. Or first, you can have one that will say discount, right? And then you will concatenate whatever that discount variable is, right? right? And then after that, you would also do what? Another output of what? The actual discounts, which is what? The subtotal minus? The subtotal minus
The discount.
the discount. So you would do something like that. So that's what this is asking for, right? So you would do a discount of 10%. Now, if the order is eligible for a discount, then calculate and display the discount. If the order doesn't get a discount, then still display the discount, but it should be 0. You can display that if you want it. Okay, it's not necessary. That is basically adding that here, if you know.
The output, so it would just be, you would just put an output under a no.
If you want to, yeah, just to say 0. Okay? Include a line before that tells that every customer receives. So this that every customer receives a discount 10% over 50%. You can include this on top, right below the address on your phone, or before the thank you. Before you say thank you, you can put that message in there, not in the middle of the receipt. Okay. So that is basically for that lab, and then some of you already submitted that, and then for this lab. So those of you that have started, you just taking your last project 4 and then adding a menu to enable the user to run a Python program all day without having to restart the program. Make questions to the user control. You would just start from where you left off, but the only thing you would do here is you would add a loop at the end, basically asking, is there another customer? So this question should not ask how many times they want to repeat, meaning that what? Don't use a for loop. That's what this means, right? Look at the loops that we covered. Don't use a for loop, you're using a while loop. So when you add the loop, also add a counter and accumulator so that at the end of the day, when the user no longer wants to continue processing another order, you would sum the grand totals, which includes possible discounts, pre-tax total, and so forth. All this can go into the main, which would still fit on the screen. All right. So this is basically a continuation of where you left this off, this assignment, right? After you print everything, then you're going to your Python and then typing. Again, if you have been doing it with every lab and every example we were giving you, then you should be able to just be at the same place when we did functions. Okay. The only thing you're adding is a loop in this after we did the functions, and look at those examples when we covered functions on working on this. All right.